Vectors. What I want to look at here is vectors. Now, you had a little look at this in level 1 physics if you did it. Maybe not if you didn't do it. I used to think of vectors as just little arrows. So you might think that's a vector. And it is. It represents a vector. Vectors are like numbers, but they've got direction. So a vector is a number with direction. Numbers by themselves are often given the name scalars. So scalars are just numbers. So if something needs to be represented by direction and it's got a quantity, you use a vector. So when we talk about speed, we might just go 20 meters per second. But if I say 20 meters per second east, I might represent it as a vector. And this would be 20 long, and the direction would represent east. So that's a vector. Now the thing about vectors is just like numbers, just like 3 plus 4 equals 7. That's two scalars being added together. Vectors can also be added together. And the way we add them together is head to tail. And we often say that. What does that mean? Well, if we consider that the front part is the head and the back part is the tail, then the way we're going to do it is by drawing our two vectors and joining them together. So if that was vector 1 and if vector 2 was like that, vector 2, vector 1, then I've now added them. Does it look like they're added? Well, I suppose it does. But what is the result? With our sum, 3 plus 4 equals 7, our result is 7. But with these little guys, two vectors add to give another vector. So that red vector is the sum of these two other vectors. Sorry, the red vector is equal to v1 plus v2. So if we call the red vector v3, then we would say v1 plus v2 equals v3. So the vector v3 also has a length and direction. So you can see direction becomes very important. It's like a way of adding up everything, but now every little bit of it has direction. Just like you can have a number, say you've got 12. 12 could be 6 plus 6. But it could also be 4 plus 2 plus 3, what's that, 5, 9 plus 3. So there are numerous ways we could add up to get 12. And there are numerous ways I could add up to get that red vector. That red vector could be made from a vector like that, like that, like that, like that, like that, and like that. Seems crazy, doesn't it? But I've joined them all head to tail. And then when you want to know the sum, you go from where you started the little chain of vectors to where you finished up the chain of vectors. And so that becomes your sum. So you can sum up as many vectors as you like. We often are just using 2. So that's adding vectors. Adding vectors is head to tail. Adding is head to tail. And the red one there is our resultant vector, or what they all added up to. Now, subtracting vectors. Just get that one out of the way. Is nearly as easy as adding vectors. What you do is, if you've got a vector, we'll call that v1, and if you've got a vector like that, we'll call that v2. If I was to add them, I think you now know that v1 plus v2 is that one, and then that one. And our resultant vector is this. Right? But if I said v1 minus v2, then it's actually the same as, just like with normal numbers, v1 plus minus v2. So when you go plus and minus, it's just like minus, right? But what's minus v2? Minus v2 is v2, but with the arrow on the other end. So when we look at that, what we do is we go, okay, v1 minus v2 is v2 but with the arrow on the other end. So we'd have to add it like this. So v1 minus v2 would give you this as an answer. So subtracting vectors, you just add the negative, and the negative of v2 is to have the little arrow on the other end. Now, we won't get into multiplying vectors because we won't, but we do need to talk a little bit about change. I think a delta, I'm just thinking. Yes, this subtracting thing is often used. I think you've come across this symbol. For example, we could have delta p. You know that delta means change in p, or whatever, it could be delta v. Change in p. If it was delta v, it would be change in v, and if that were represented velocity, then that means we're talking about a velocity change, and it's v final minus v initial. So if you've got two vectors, one that represents v initial and one that represents v final, then this is one of the classic places that you have to do a vector subtraction. So you go, okay, what's this? V final down minus v initial, but v initial goes that way, so it must be that way, but with the arrow on the other end. So it goes like that. So that becomes vf minus vi, and we would then draw our resultant vector, and that is delta v. So we often use that. Yeah, couldn't quite see it, could you? So we had vf minus vi gives you delta v. That was vi. We had to put the arrow on the other end for minus vi. So that gets used again and again in physics. So something we really did have to look at. Alright, so that's it with adding and subtracting vectors.